In this lecture, we're going to step away from the three-way comparison operator a little bit and focus on the equality operator. And we're going to see that we can actually tell the compiler to generate an equals operator for us without really going into the details of setting that up ourselves. Let's see how this can work. Here we have a simple class called item, and we have our member variables in here. And what we want is to set up an equals operator for this class. And what we want is really member-wise comparison. We want to check if the A member variable is equal to the other object A member variable. And we want to do the same for B and C, and that's what we want. If this is the kind of comparison we want to do for our own class, then we can tell our C++ compiler that supports C++20 to generate an equals operator for us. And this is the syntax. You say the return type, which is going to be bold because you are already comparing things. You're going to say that you want operator equals, that's going to be the name of the operator. And then you're going to specify the second parameter. Notice that this operator is done as member function. This is really important to notice in C++20. And then we're going to say that it is a const member function because we don't intend for this to modify our object really. And then we're going to say equals default. This is going to tell the C++ compiler that we don't really want to set up our own equals operator. And the compiler is going to generate one for us, and it is going to work out of the box. And this is really cool. So let's see what kind of operator the compiler is really going to generate. The compiler is going to generate an operator that does member-wise comparison. So it is going to compare the A member variables. Then it is going to compare the B member variables. After that, it is going to compare the C member variables. If they happen to be all equal, it is going to return true. And if that's not the case, we're going to hit the end of our if statement here and return false. This is a possible implementation of the operator that the compiler can generate for you. Again, the message here is that this compiler generated equals operator is going to do member-wise comparison. So make sure that this is what you want before you default your equality operator. You should really know this. Another thing that is really cool in C++20 is that the moment you set up an equals operator, the compiler is going to generate a not equals operator for you for free. And this is really cool. So the moment you set up an equals operator, the compiler is going to say, I can use this operator to generate other operators and make the life of the developer really easy. So you only have to maintain an equals operator, and the compiler will take over the job to maintain all these compiler generated operators. In this case, it happens to be the not equals operator, and this is really cool, and you should really know this. Okay, so because of that compiler generated not equals operator, we will be able to do something like this. Even if we only have an equals operator, we can set up two item objects and we can see if they are equal or not equal, and this is going to work well. Another thing I want to cover before we hit Visual Studio Code and start playing with code is the concept of implicit conversions. If we go back to our item class, we're going to see that we have a constructor n that takes an integer. And what this means is that the compiler can use this constructor to build item objects using fundamental types like int or double. So if we pass a double, the compiler is going to implicitly convert that to int and use that int to create an item object. This is something we could do. So if we support implicit conversions, the compiler will be able to really flip things around and make things work better. One thing worth noting here again is that our operator is done as a member function. So in principle, we should really be able to use implicit conversion on the second operand, because when your operator is done as a member function, implicit conversions don't work for the first operand. You should really take a moment to let this sink in and understand what I mean here. But for our default equals operator here, implicit conversions are going to work even for the first operand. And this is because of the magic that C++20 is really going to do. Let's look at a simple example here. Okay, if we look at our first two lines, the two operands are item objects. So this is going to work just fine because we can call our operators on our objects here. But if we look at these other two lines, we're going to see that I1 is compared to 12 in the second position. This is going to work well because the operator is implemented in an item object. So we're going to call operator equals on I1. This is going to work just fine. But on the line here, the literal is in the first position. In older C++ code, this would give us a compiler error because we don't support implicit conversion on the first operand if our operator is done as a member function. But in C++20, this is going to work. I want you to take a moment and appreciate this. Then I am going to tell you the secret that C++20 is using. We have the same situation here for the not equals operator. If the operand in the first position is an object, this is going to work just fine. Nothing surprising here. But on the second line, a literal is in the first position. Again, this would give us a compiler error in older C++ code, which is not using C++20. But in this case, it is going to work. So what is the magic here? What is the compiler doing that is allowing us to pass literals in the first place and be able to call operators on these literals? This is really weird and it wouldn't work in older C++ code. So what the compiler is really doing is nothing complicated. The compiler is just rewriting the operation and make sure it uses an object it can call the operator on and still keep the same result we would expect for our operator. So for example, it is possible for the compiler to flip things around if we are comparing A to B using an equals operator. The compiler is smart enough to see that we're going to get the same result if we flip the operands and say B equals A. And this is really smart. So if we need a not equals operator, what the compiler is going to do is to negate A equals B, and we're going to get the result we would get if we said A not equals B. Another thing the compiler can do if A happens to be a literal and the compiler has no way to call an operator on A, the compiler can flip things around and say not B equals A. And in this case, we might get B to be an object, and then we can call our operator on that. So what the compiler is really doing is rewriting our statements, trying to find an arrangement that could work and still give us the same result that we expect in our statement. And this is really cool. So let's go back to our code and re-examine potentially problematic lines that would otherwise give us problems. So in this case, on this line here, we are trying to compare 36 to I2. The compiler is going to see that it can't really call an operator on a literal, which is 36. The compiler is going to try and flip the operands around. And then it is going to say I2 equals 36. The compiler is going to see that I2 is an object and it is going to call an operator on this. And we are going to still get the result that we expect with this statement here. And this is really cool. The same is going to happen for the not equals operator. The compiler is going to flip things around and say I2 not equals 36. And this is going to work just well. We're going to get our result here. And this is really cool. Okay, now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is defaulted equality operator. We're going to grab our template files and put them in place. Let's do that. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean up a little bit. We are going to set up our class in the main CPP file here because this is going to make things easier here. We have an item class, nothing complicated. It is exactly the same thing we saw in the slides. We have three member variables, A, B, and C, and we have a bunch of constructors. The default constructor is defaulted. We have a constructor that takes an integer n. This is going to allow us to play with implicit conversions, and this is delegating the construction work to another constructor, which is going to take the parameters and initialize them using an initializer list here to pass the data in our member variables. The important thing to note here is that we have an equals operator which is defaulted, and this is the syntax you use. You say the return type, you say the name of the operator. We are going to specify our second parameter in here, or the second operand. This is a const member function because we don't expect it to modify our object. It is not going to be modifying any of the member variables here. And we defaulted using the syntax here. And you see that it is the same thing we used for the constructor here. So we can say default and let the compiler generate an equals operator for us. Now that we have this in place, our class is going to support the equals operator, but it is also going to support not equals, and this is really cool. The compiler is basically going to use our equals operator and generate a not equals operator. And let's try and see what that not equals operator could look like. We could say bool and say operator not equals. We're going to specify the second parameter. It's going to be an item. And we're going to pass that by reference. We can say write operand, and it is going to be a const member function. And we're going to use our equals operator. We're going to return not this equals to write operand. We can say something like this. And this is going to work. And this is a possible not equals operator that may be generated by the compiler using our equals operator. Notice that I am dereferencing this pointer because I want to get to the actual thing that is pointed to and then compare that with another reference we get in our parameter here. This is a syntax you might use. But again, we are using C++20. We don't need to put this operator in because the compiler is going to generate that for us. Another thing to note if you default your equals operator is that the compiler is going to do member-wise comparison. So it is going to compare A, then B, then C, and they are going to be compared in the order in which they are declared. In the slides, we had a chance to look at a possible implementation for the equals operator that the compiler might generate for you. And again, we're going to look at it. First, we're going to compare the member variable A's in our object. Then we're going to compare the B member variables. Then we're going to compare the C member variables. Things are going to be compared in the order in which they are declared, and you should really know this. Now that we have this class in place, we can head over in our main function and play with it. The first thing we might try to do is set up two objects. For example, for the item class, we might say item I1 and I2 and put in the data to initialize our member variables. Then we could compare these things. Notice that we didn't really put in a not equals operator, but this is going to work in C++20. The compiler is going to generate a not equals operator for us, and it is going to be used in our statements here. Let's build and see that this actually works. We're going to use GCC, our favorite compiler. The build is going to be good. We're going to bring up a PowerShell window. We're going to run Rooster, and we're going to see that I1 is equal to I2 because they have the same data inside. We are doing member-wise comparison, and the first member variables are going to be equal, the second member variables are going to be equals, and the third member variables are going to be equal. So I1 is equal to I2. And if we use the not equals operator, we're going to see that I1 is not equal to I2, and we're going to get a false because they are equal now. But if we try to modify at least one of the member variables, let's change the third parameter that we pass for I2 here, and we're going to build again. Okay, the build is good. We can clear and run Rooster. We're going to see that I1 is now not equal to I2, and I1 not equal to I2 is going to return true, and this is really cool. Another thing you should know is that implicit conversions are going to work even if we try to use implicit conversion on the first operand. Notice that again, we are doing this equals operator as a member function. So by what we know in old C++ code, if you are doing a binary operator as a member function, implicit conversion shouldn't work for the first operand. But in C++20, that's no longer the case. Implicit conversions are going to work even if the operator is done as a member function. We are going to go down and put in other pieces of code here. We're going to try and compare the data in our objects to literals. Again, implicit conversions are going to work because we have a constructor that may be used by the compiler to convert from int to our item here. So what we're going to do is try and compare I1 to 12, a literal number, and we are going to do that in this statement here. And we're going to try and compare 36 to I2. And this is going to be a problematic line in all the C++ code. So the first thing the compiler is going to do is to try and call our equals operator on the 36 literal. And that's going to fail because this is an object. We can't really call methods on this literal number. The compiler in C++20 has gotten smarter. It is going to try and flip things around in a way that it is going to keep the same logic that we are trying to apply here. So the compiler is going to say I2 equals to 36. And now an object is in the left position, and we can call an operator on this object and still get the same result we would expect if we had a literal in the left position here. This is really something I want you to know. So we're going to have the same case for our last line here, where we have 36 in the first position. The compiler is going to flip things around and then call our not equals operator on the I2 object. And we're going to get the same result we would get from our statement here. And this is really cool. Again, the compiler is going to be using the rewrite rules we described in our slides here. For example, the statement A equals B can be rewritten as B equals A, and we're going to get the same result. The statement A not equals B can be rewritten as not A equals B, or as not B equals A, and we're going to get the same result. The compiler is going to try all these combinations until it finds a suitable one that could allow it to call an operator. And if it doesn't find one, it is going to give you a compiler error, and that's not going to work. Okay, so now that we have this in, we can try to run this through GCC. We're going to see that the build is going to be good. We're not going to get any compiler error. We can clear and run Rooster, and we're going to get the results that we expect. I1 equals I2 is going to give us false because they are not equal. I1 is not equal to I2. That's going to be true because they are not equal. I1 equals to 12. This is going to be false. We're going to get the result that we expect. 36 equals to I2. The compiler is going to see that we have a literal in the first position. It is going to flip things around and then call the operator on I2. And we're going to see that 36 is not equal to I2. We're going to get a false. I1 not equal to 12. This is going to be true because they really are not equal. And 36 not equal to I2. The compiler is going to see that we have a literal in the first position. It is going to flip things around and then call the operator on I2. And we're going to get that 36 is not equal to I2. This is going to be true. This is really all I had to share in this lecture. I hope you found it interesting. This should give you a smooth introduction on things we could expect from doing logical comparison in C++20. The compiler is going to see the things you do and potentially rewrite them to get things to work, and this is really cool. Another thing I should really advise you to do is to set up your logical operators as member functions in C++20, and the compiler is going to flip things around and make them work even for implicit conversions when it needs to do so. The syntax to default your equals operator is what you see here. The compiler is going to use that to generate a not equals operator that we can use in our code. We are going to stop here in this lecture. In the next one, we're going to show you that the defaulting that we just talked about in this lecture isn't always going to work, and you might need to set up a custom equals operator for your C++ types. Go ahead and finish up here and meet me there.